Hi, my dear. How are you? The navigator. Here I am. Water quality subject. Indeed, it is very important subject. And for simplifying, we'll divide the presentation to many parts such as Part A. Effect of using poor water quality in agricultural field and the quality evaluation. Part B. Poor water quality, management and the crop selection. The rest of water quality subject parts such as Part C. Osmotic regulation treatment and additional leaching fraction. Part D. More frequent irrigation and choosing the suitable irrigation method. Part E. Irrigation and cultivation practice. Also, there is a water quality subject part such as Part F. Drainage requirements, amendments, reuse strategies, and wastewater treatment. And Part G. Desalination plants and reference. My dear, water quality subject. Part A. Effect of using poor water quality in agricultural field and equality evaluation. Indeed, deficit and seldom of freshwater resources on the globe represent a very incurable problem to satisfy billions hungry of humans in the world. Hence, management of poor water quality in the field of agriculture, in spite of its severe problem, should be discussed as a comprehensive solution for achievement the food security in the world, especially in arid and semi-arid regions, and while there are no enough rains under the impact conditions of climate change threats. Generally, fixing evaluation is not possible or until right when considering water quality for irrigation. Consequently, there are many factors which should be taken into consideration on this scope, such as water resources availability, soil original and characteristics, geological conditions, reaction of soil with water, planted crop species, groundwater conditions, climate, management practice, irrigation method, human culture and skills, economic conditions, and policy decision strategy. Effect of using poor water quality in agriculture. The common problems that result by using a poor water quality in irrigation can be summarized as number 1. Salinity problem. Generally, using poor water quality on irrigation should be caused and continually accumulation of salts in the soil supply, which creates an undesired positive salt balance in soil, which affect negatively on root distribution zone and butter, and therefore effect on plants growth and crop yield, in addition to increasing the osmotic pressure in soil solution. Also, number 2, permeability and crusting problem. There are many specific ions in water, which more excess of it causing on reducing the soil permeability. Hence, creation non-adequate media for supplying plants by water, which affect significantly on crop yield in addition to the toxicity problem. Number 3. Toxicity and nutrition and balance problem. As toxicity problem occurs when certain ions in irrigation water are absorbed by crops and accumulate in concentration that affect on growth features and yield. Usually, toxicity is related to one or more specific ions such as sodium, chloride, and boron, or lack of calcium. While number 4, miscellaneous features as there are many features which should be taken in consideration when using a poor water quality, such as excessive vegetative growth, delaying growth at maturity, unhealthy growth, deposits of leaves and fruits, dwarf growth, and deformation with less sized fruits production. Water quality evaluation. Suitability for agriculture, as good water quality has the potential to allow maximum yield and field income under good soil and water management. The suitability of water for agricultural use is determined by its potential, which causing problems and clearly affect negatively on crop yield and other farm activities. A completely laboratory analysis should be carried out for water samples for calculation its contents of total dissolved salt, crusting, and anions to calculate the adjusted sodium absorption ratio. Moreover, determination of different ions is necessary also for evaluation the toxic levels for drinking livestock and poultry in farms. Calculations of adjusted SAR equation with its parameters. Really, it is very important, my dear. Look and look again. Calculation of residual sodium carbonate RSC equation is clear in front of you, my dear. Look, it is very important. Table showing the guidelines and degree of expected problems on using water for agriculture. Look, my dear, to the irrigation problems concerning salinity, permeability, adjusted sodium absorption ratio under different clay species, specific iron toxicity, miscellaneous, and pH also. Table showing the guidelines of maximum concentration of trace elements in irrigation water. Reference to Food and Agriculture Organization FAO in 1985. Table showing the guidelines of water quality for livestock and poultry. Table showing the guidelines of toxic different elements in water for drinking livestock. Table showing the calculation of the irrigation water alkalinity components in adjusted sodium absorption ratio equation. Water hardness is the ability of using water in domestic washing activities. Hard water has high mineral content and often indicated by lack of suds formation through agitation of soap in water during the washing process. Moreover, hard water forms white deposits on the inside surface of pipes, which causing irritative looking and hence restricting flow of water in pipes, especially in aqueduct and culvert structures, in addition to causing corrosion in galvanized pipes. Water hardness is determined by the concentration of most multivalent cations, which are too positively charged and more, such as calcium and magnesium cations, while iron, aluminium, and manganese can also be present at high levels at some cases. There are two types of water hardness, such as temporary and permanent hardness. Temporary hardness is due to the presence of calcium bicarbonate and magnesium bicarbonate, while permanent hardness is hardness which can't be removed by boiling water. permanent hardness equal calcium hardness plus magnesium hardness, expressed as equivalent of calcium carbonate. Hence, the permanent water hardness PWHT expressed as equivalent as shown in the enclosed equation. Table showing the guidelines of the permanent water hardness by different units. World Health Organization concluded that both calcium and magnesium are beneficial essential minerals for human health, as using hard water doesn't appear any convincing evidence effect on human health, and recommended also the maximum and the minimum levels of both minerals in drinking water, such as 40 up to 80 parts per million and 20 up to 30 parts per million for calcium and magnesium respectively. My dear, there are several indices are used to describe the behavior of calcium carbonate stability and corrosivity in water as follows. Regular saturation index is a calculated number used to predict the calcium carbonate stability of water as shown in the enclosed equation. Longer saturation index parameter. Look, my dear, it is very important. Longer saturation index LSI really is sensitive with temperature. Anyhow, assessment of LSI can be done by changing the water chemical either by decreasing calcium or adding acid to lower the pH values. Look, my dear, also regional stability or saturation index uses database of scale thickness measurements in municipal water systems to predict the effect of water chemistry, as shown in the enclosed equation. My dear, Pacoria's scaling index also uses an equilibrium pH rather than the actual measured pH to account for the buffering effect, and for that reason the scale is known as practical scaling index, as shown in the enclosed equation. Moreover, Larson's cold index describes the corrosive water towards multitude. This index is the ratio of sulfate and chloride to the alkalinity in the form of carbonate and bicarbonate, as shown in the enclosed equation. More than Otto-Thomson index accounts for the impact of pressure and partial pressure of carbon dioxide on the pH of water and stability of calcium carbonate, while Steve Davis index is calculated such as LSI corrected by K values depending upon ionic strength and temperature, as shown in the enclosed equation. Look, my dear, and follow up by yourself. It is so clear and easy. Water sample analysis curve. Look, my dear, to the example which giving the chemical analysis of water sample and its solution. Follow up the calculation by yourself. It is so clear and easy, my dear. My dear, follow up the steps of solution the problems as shown in front of you. Take it seriously, my dear. The report of water quality analysis can be concluded depending on the result of calculation data followed up, my dear, by yourself. It is so clear and important. My dear, follow up the rest of report's recommendations. It is very important, really. Goodbye.